everyone, welcome back to the channel and to another video in our Databricks series. In our previous video, we explored the theory behind Delta Lake, what it is, why it is important, and how it enables features like ACID transactions, versioning, schema enforcement, and time travel. If you have not watched that video yet, I would highly recommend checking it out first to get the complete understanding. I will quickly show you where you can find it on my channel. So if you go to youtube.com, then if you search for AI to Deutsch, then for now there is only one video which you can easily find in video section. Please watch this video if you haven't seen it yet, because in this video we are doing hands-on with Databricks Community Edition to explore the core features of Delta Lake. Which includes like creating and interacting with Delta table, upserting data using merge, understanding schema enforcement and evolution, working with managed and external table, restoring previous version of data with time travel, and cleaning up obsolete data with vacuum. So by the end of this video, you will know how to use Delta Lake in real world data engineering workflows inside Databricks. So let's get started. You would need a Databricks account for that. So just search for databricks.com, then you can click this try Databricks, and then we will see a page like this one. And so for this video we are using Databricks Community Edition, which is a free version of Databricks that gives us everything we need to get started, like a notebook, a cluster. It's great for learning and for small projects. That's why for this tutorial we are choosing Community Edition. In later videos we will move to cloud setups, and I would be choosing AWS cloud. Okay, so here we will, if you see below, we will see Databricks Community Edition. You click here, enter your email address, and then continue, and then you will get a code on your email. So just like 2-3 steps. I'm not doing this because I have already done this, but it's very simple. So once you created your account, you will, let me close this, you will see something like this one. Okay, this is your UI after you successfully create your account. So here let me give you a quick walkthrough for this one. So here we have a workspace where you can have your notebooks. Basically the recent tabs, you can search option. Yeah, catalog is where you will see your data and files which you are going to store or create. Workflows, it's not enabled for Community Edition, but in this tutorial we don't even need this one. It is mostly, I think, used for scheduling or something, but let's not worry about this. Compute is for creating your cluster. So okay, so and before that what you can do is go to your settings. In the setting, go to advanced and enable this DBFS file browser. By default it will be off, so please enable it. Okay, because this is your Databricks file system. This is where we are going to store our data, basically the CSV files and everything which we are going to work on this today. So I would please enable it. Okay, so now, and then you click new, and then you have to upload your a CSV file. So you would need a CSV file which has a dummy data basically. So any CSV file with dummy data you can upload, and this will be stored in your DBFS directory, which is file store tables. Inside this file store tables, basically you can upload your file. Drag and drop also works. S3, we don't have S3 right now. DBFS is same as here, DBFS, so you can choose the location here as well. Okay, so by default it stores in the DBFS directory. So let's upload a file here. So I'm going to drop my file in this location, and then we see two options here: create table with UI, and we see create table in notebook. Okay, so we are going to do create table in notebook because this gives us more flexibility as a developer, and in with this one we can handle file path explicitly, right? So with this we will have more control, and this is like create table with UI. So let's see what this gives us. So it asks us to attach a cluster. So one cluster, I have it here, and then preview table. So basically whenever you want to run any notebook, you need a cluster as well. I would explain about cluster in a while. Yeah. So you basically attach a cluster and then you preview table. So basically it gives you, yeah, and create table. So we will not going to choose this option. We will do create table in notebook. Okay, so let's do that, and this is the notebook which will automatically be created for you by Databricks with some options. Here a brief description about DBFS. Here this is your file, and these are options, CSV file options, and here you are basically reading the file and displaying it. I have already created my own notebook, so I will be using that one, but this is the by default notebook which is automatically gets created. Okay, so let me, and this notebook you can find it in if I go to workspace, then you can find it here. Okay, this is one notebook which is now automatically created, but now I am going to use this one which I have already created. Okay, so before running that, I made sure, before uploading the file, I just made sure that path is empty. So I already ran this command here. Basically I am removing everything which was present in this table. Okay, so as you can see, when I am displaying this, it was saying no, cannot infer schema from empty dataset. But now if I will run it, I will see my file is now here because we have just uploaded this file. Okay, so now this file is here. Okay, so now let's, and also if you want to see it in the UI, what you can do, you can basically come to your catalog and you have this DBFS option, right? So our file was stored in tables, and then this is my CSV file which is there. Okay, so now let's go back to our notebook. Before we run anything, we need a cluster. Okay, why? Because a cluster is basically the compute engine behind Databricks. It's what runs your notebook. Okay, so you write the code, like you will write your code in the cell, but the actual execution happens on the cluster. So without a running cluster, notebook won't be able to process any data. That's why you need a cluster for that. Okay, in Community Edition, Databricks gives us a small managed cluster for free, so we don't need AWS or any other setup. It's all managed by Databricks. That's why it is perfect for like hands-on learning. So how you can create a cluster? Go to compute, or another way, now as your notebook is already open, you will see one option here. Right now I have already created a cluster, so you will see create a new resource. One way is through this one. You create a new resource and you can create, attach and run. So by default, here you will just give any name. By default it is taking 12.2 runtime. There are different runtimes, but yeah, I just kept it whatever default it is coming, but you can choose higher runtimes as well, but it doesn't matter for this tutorial. So yeah, you can choose this one, whatever is coming, and then create, attach and run. And once you do this, then you will see something like your cluster it will take like maybe 3 4 5 minutes to start your cluster. Okay, so and the another way to start a cluster is you go to compute and then you create compute, and then you will see something like this one, and here basically you see more information: free 15 GB memory as a Community Edition user, These you can keep it by default, and then you click on create compute. Okay, so for me one is already active, that's why it is saying you already reached maximum number of active clusters. But if you are doing it, if no cluster is active for you, then you can easily create from here. Okay, then now moving on to our notebook. So this is my file, and this is the same notebook which you also have, so the same structure I also got. And file location, I'm giving here the file location. Basically in your case you would also have a CSV file path, but yeah, for me I have just only one CSV file, so we can write like this also. Infer schema, make sure to make it true. In your case it will be false. First row as header, yeah, you can make it true as well. Delimiter is comma separated. Okay, so here I'm saying I'm reading a file. This is my file. Infer schema, header, these will take from here. Separator is my delimiter. These variables will be taken from here and load from this file location. So in this file location, file store tables, we have this CSV file, right? So if I run this, then we see this CSV file is here. Okay, so this reading the file should be clear. So this is just we are reading our CSV file. Okay, so now let's write our file as delta table. Okay, so to write, what we will do, we will say, okay, we want to write in the format delta at this location. So we are defining a dbfs location in this path. So we are creating a new folder, my delta table, where we are basically writing our delta table, and mode is our overwrite. Okay, and after writing this, we can also now see, okay, what we have written in this path. So when we will run this command, basically here what we are saying, like, okay, display the content of this path. Okay, so, and one thing here, dbfs is basically your Databricks file system. Yeah, so for now you can think of it like it is basically the file which you will be storing in Databricks will be inside your Databricks file system. And to access those files which is present in your dbfs, we use dbutils. Okay, so I'm going to create another video on dbfs and dbutils, but for this video I think that is enough to understand, like, okay, if you want to read any file which is present in your dbfs, we will use dbutils. If the file fs is the file system, we are going to list every files which is present into this location. So at this location, what we have done, so at this location we have written our delta table. So if I display this, then we see here we have a parquet file and a delta log. Okay, so if you remember from our theory video as well, whenever we write anything in our in any path, then we see two things. One is our actual data, which is the parquet file, and a delta log is also getting automatically created, which is nothing but contains your transaction logs. Okay, and these transaction logs, if you remember, contains the operations what we have performed on our data, right? And we can also see this data from here. So if we go to catalog, we see this dbfs file, then table, and then now this was our CSV, but this is the folder which we have just now created. And if I go inside this, then we see this file. Okay, here we see a lot of parquet files because I already ran few cells after this cell, so that's why. But here in our notebook we can see that at this point we have done our first operation. That's why we have this one parquet file here. And if I go inside this delta log, so here again display the content of this folder. So I am seeing here this JSON file which contains what is the operation that we have performed on this table right now, right? And so this is the file which is most important to us. And we also see these .crc file and some S3 optimization files. So what are these? So crc file is nothing but for every JSON file, a corresponding crc file is also getting created automatically, it will be created automatically. It stands for cyclic redundancy check. It's essentially a checksum file that ensures the integrity of the JSON file, verifying that it has not been corrupted. Okay, so when Delta Lake reads the JSON file, especially during read operation or during recovery, it uses the CRC file to verify that file is original and has not been modified. Okay, this helps in detecting corruption or data tampering. That is the use of CRC file. And this S3 optimization files which we see here is basically when we are working with delta table in Databricks and perform a write operation. So whenever we do some write operation, a temporary folder with the name like S3 optimization, so here we see 012 S3 optimization 012 appears in your file path. This folder is part of how Databricks, or more specifically how Apache Spark, ensures data is written safely and atomically to cloud storage system like S3 and DBFS. So basically it ensures consistency, durability and atomicity during write, and Databricks uses temporary directories like this, okay, to stage the files. So once the entire write job completes successfully, Sparks moves the file from this temporary location to the actual destination of your delta table. Okay, so if you see this folder, don't worry, it's part of the internal optimization process to ensure your data is safely written. Okay, so because our main focus is .json file, which gives us basically all the information like what operations was performed on this, right, as we discussed in our theory video as well. Once again, if you have not watched the theory video, I would recommend please watch that video as well. It's not long. Yeah, so let's move on. So moving on, now let's read the delta table. Okay, so we are reading this delta table through read from this path, and this is the same basically the data which we had in our CSV files, right? So this was our CSV file, same data, and we are just up till now we have just written and the same file in delta format. So where is it? So here, so this is the data which we have till now. Okay, so now let's perform some operations on it and see some features of the delta lake. Okay, so now let's suppose we are creating a new column, right? With column, so we are creating this column called new column and filling every value with new. So now our data looks like this one. So now we want to write this data in our delta table. Okay, so now let's see one of the feature called schema enforcement. So now we have this data, right? Now let's try to write it. So how you will write? We will say, okay, we want to write in delta format and mode overwrite and save in this path. Okay, so this is how we have written previously as well, right? So if I go up, so here this is how we wrote previously, write format delta overwrite and this location. So the same way we are trying here the same way to write our file, but we get this error, right? A schema mismatch detected when writing to delta table, right? Because here now initially we had only these two columns, but now we have one more column, so there is a schema mismatch. So that is where this schema enforcement is holding us from writing to the delta table. So this is one of the features which we have, and to do this it is suggesting to enable schema migration, please set option merge schema true, right? So here we are basically adding a new column. We did not do anything, we are just adding a new column. So it is suggesting like, okay, let's use this merge schema. So this is your schema evolution. Okay, so using merge schema true. So let's try to write using this option. So we are saying, okay, I want to write in delta format, mode overwrite, and now we have also added this option of merge schema true and this same path. This path is same. Okay, and now when we will display our table, so this when we write this, this command was successful, right? And if we display now the content, now we see a new Parquet file is here. Okay, initially we had only one Parquet file, and this is now the second Parquet file. Okay, so from our theory video we also know that it is every operation we do, it is keep on appending, right? Which is basically helping us in time travel, which we will see shortly in this video. Yeah, so now we have this another Parquet here, and if we go inside our delta log where we have our transaction logs, so let's display the content of this delta log, and we now here see the another JSON file. So initially we had only 000 JSON when we write it for the first time, but now we also have this one. Okay, another transaction, because we did another operation and it got appended here. And let's do another operation one more time. Like now what we are doing, we are dropping this new column. Okay, so we had this new column, so let's drop this column and add another column. Okay, so we are dropping this column and we are adding another column with this value new. Okay, so if we display this, we see this, now we have this table. Okay, so again if we try to write it normally, this will again fail because our schema has changed again. So what we will do, we try to use this merge schema option. Okay, so we again used merge schema and this operation was successful. Now let's see how our, now if we try to okay, so now let's see, first display the content of our my delta table, right? So now we see another Parquet file is here, and if we see the content of our delta log, then we will see another JSON file because we did another operation and another JSON file got appended here. Okay, so up till now everything looks fine. Now let's see the content. Okay, now let's read this file, because, and yeah, whenever you are reading your delta table from this path, the latest data which is there, so whatever the latest operation you performed, you will read only your latest data basically, right? So when we will try to read this, now here what we see is we have this another column which we have created, because in this operation our last operation was yeah, here our last operation was we are dropping this new column and we are creating this new column, add another new column, right? So while reading, we see here, okay, we added this new column as new, but here we see still new column which we have dropped. In our command we dropped this column, but while reading it we still see this column. Okay, but all the values are null. So why this is happening? Because we have used merge schema while writing the file. Okay, and because of this merge schema, it did not actually drop that column, though we see that column is dropped from this data frame, but while actually writing it, because we used merge schema, and when we actually read it, we see this new column is still there with null values, right? But we don't want this, right? So what, to solve this, what we can do, we can use another option which is called override schema true. Okay, so instead of merge schema, what we are doing this time, we are using override schema, right? And before that we are performing this another operation here. We are dropping now these two columns, another column and this new column. We are dropping these both the columns, and now we are saying we want to create a new column, right? Basically a third column. And now this time when we are writing this delta table in this same path, we are saying overwrite my schema. Okay, and now when we read it from this, now when we read our delta table, then it says okay. So this is the expected behavior now, because we dropped these two columns and we added this new column, so now this looks fine. Okay, so this was your schema enforcement and schema evolution feature of delta lake. Okay, I hope this is clear till now. Now let's understand how time travel works. Okay, so this is another feature which we have in our delta lake. So okay, let's read this delta log in, because we know delta log has all the transactions which we performed. If we display the content of this delta log, now we have all these JSON files. So we have performed 4 operations till now on this. So we see all the JSON files here, and we have this option called version as of. Okay, so now I want to see what was my data in my version 0. So if I'm reading this delta table using this option of version as of 0 from this path, then it is giving me this. So which is correct, right? Because our initial CSV file was like this only, right? We had only 2 columns. So this is what we are getting. And if I read version 1, then okay, then in version 1 we added this new column. In version 2 we had this, right? We dropped this column and we created this column. In version 3 we basically dropped both the columns and have this column, right? So now we can see all the operations which we performed before. So that is the benefit. How we are getting this? That is the benefit of your delta log, because we have all the versions available in our as our transaction logs here. So we can basically read, we can go back and see what operations was performed in other versions, previous versions. Make sense? And it is just to show, like if we give a version which is not available, like 4, which basically doesn't exist, so cannot time travel delta to version 4, available versions only 0 to 3, and this is just to show you guys. And now because of this version, now let's suppose we thought after let's suppose we thought, oh, this is not right, whatever data we had here was actually correct, so we want to have this in this again. Okay, so how we can do that? So it's simple. We will read this delta format. Now we will say I want to read this version 1 from this path. Now in this data frame, now we have this version. Okay, and now if we write this old version into this, if we write this using override schema into this path, then what will happen? Another parquet file will get created, another operation we are performing, and now our latest data will be this one. Okay, so this is how we traveled back in time to load the previous data. Okay, so this was your time travel feature. So I hope this is also clear. Let me know in the comment section if you have any doubts till now. Yeah. So now let's look at the transaction log. Okay, so we are seeing here in 001.json. So what happened in this uh, transaction? Okay, so when we display this JSON file, we see here we have different columns. We have this add column, we have this commit info, and we have this metadata, and we have this remove. Okay, so whatever operations which we are performing is getting tracked in this JSON file. Okay, so it's, so if I hover over, if I click this one, so it says, let me, okay, so it says data change true, yes, modification time was this one, and this parquet file was getting created, added this parquet, we added this one, and number of record was 6, minimum value, maximum value, uh, insertion time. So these kind of information we can get from here, right? And data set name. So this is how basically you are tracking. So this is your transaction log which helps in tracking, right? And this is the commit info. So here it says, okay, the cluster ID was this one, engine is this one, we perform the write operation. So in commit info we are basically getting the operation type which we performed. So we performed this write operation. So with this JSON file we can read this timestamp and user ID, what was the user ID, who performed this is the user name, who performed this operation. So we get all these information from the logs. Okay, and metadata, if we see metadata, then we see, okay, Created time was this, format id, party we did not do any partition, so there is, it's empty. Schema string, so we see the schema here. So, and in last one we had this remove. So if we see this, then it says okay, data change true, and deletion timestamp was this one. So all these tags, basically all the information, right? And part was this one, so we removed this path parquet file. So yeah, so all the things which we are performing is getting stored in our transaction logs. Okay, and it is not necessary that we always see these 4 columns all the time. Like right now in this JSON file we are seeing add, commit info, metadata, and remove, but it might happen that in some of the operation we are not removing anything, right? Or in some operation we are not changing any metadata. So in those JSON files we will not have these columns. Okay, but in our example right now we have this one, but yeah, it depends on the operation what we are performing, these column will change. Okay, so now let's see our managed and external table. Okay, so in our theory we talked about these two tables, right? One is managed table and another one is external table. Basically in external table we are giving a location as well, right? We are basically telling where our data resides, so we are controlling the location in the external table, right? And we are here, we are saying create this table using delta, and but my location is this one, so my actual data file is stored in this one. Okay, so when we create table and when we select star from table, then we see now the same data is here, right? And after creating the table where we can see it, so if we see here in the catalog we have this hive meta store, right? Because this will store the schema as we discussed in our theory. So if I go to hive meta store, so right now we have created this my table, so my table got created here with the schema here, right? And if I do any operation on this table, for example update, I am updating this table, I am setting my dataset name, so this is my column name, dataset name, right, to this value wherever my new column is equal to new. So all the rows where my new column has new value, change the value of dataset name to updated name. In our case all the rows has this new, so all of them should change, right? So it says rows affected, number of affected rows are 6 because we have only 6 rows and all of them has new value. And if I see now select star from my table, I see here now this name has changed. Initially we had app visibility, now we have updated name. Okay, so now interesting thing is, because we did this operation on our table, right? And we have while creating this we said the location, we set the location as this one. So if we see our delta log, okay, then we see here another JSON file got created. Okay, so if I see these two versions, if I'm displaying here, I'm displaying version 3 and now version 4. Now here we see this was the old version, right, app visibility, and this is the new one which we changed from our SQL command. So we did not uh, directly performed in our main this path, but we change this through our table, right? So this will give you, so basically this is your external table, right? So whatever operations you perform on your table, now the changes can be seen in your actual file location as well, right? So if I go here, if I read the data now, if I read the data from this table, we can now actually see this updated name appearing. Okay, so this was your external table, right? And we already know from our theory video what is a meta store, why it is needed, and what is a metadata basically, right? So now we can have this as table, right? So this was that was our external table. Now let's see our managed table. Okay, so in our managed table we know that we don't define our location, so we are saying create my table as select star from this table. So we are not basically giving this option. Where is it? We are basically not defining this location, right? We are just saying create my table from this. We are from this file. So we are selecting everything. We are just saying create my table using this one. Okay, and after creating this, then we see here my managed table is appearing here with these columns, right? And now if I do describe, okay, describe detail, okay, my table, this was my external table. So we see the, if we see the location here, so this is the location where my actual data resides, right? Because if we go to here catalog, then dbfs table, my delta table, this is what we have created. So this is my actual table, right? So this is what we are getting here in case of external table. But if we see describe, we do describe detail my managed table, okay, so here we see the location is different. Okay, so basically your Parquet file, your delta log, everything is now stored here. Okay, so let's see what we have written here. The new managed tables data is now stored in the default managed location, this one. Okay, table structure in the left panel here shows the schema, which is the metadata stored in the Hive meta store. So this is the metadata stored in our Hive meta store. Okay, but the actual data lives in delta file, Parquet and delta log under the managed path. So if we see this managed path, so this is our path. So we copied this path here, we copied this path here, and if we display the content of this path, we see here a Parquet file and a delta log. Okay, so this is why, because this is managed by Databricks, right? And if I do some operation on this path, so I'm saying my Spark table is this one with column, I'm adding a new column transformed and with value yes, and I am writing this in delta format with merge schema true because we are adding a new column, and saving it in my managed table. Then if I display again the content of this path, then we see here is the Parquet file, another Parquet file got created, right? So and inside our delta log there will be another JSON file. Now it will work the same like what was happening before, but now everything is happening in this path because of this managed table. Okay, so if I do now select star from my managed table, I see here new column is getting created, what, because this is what we have created here. So now this is our new column here, and if I do this select star from my table, this was my external table, I still see here this was my previous data which we had. Okay, and now if we drop this, okay, my managed table, so we know that from our theory video we know that if we drop this managed table, then it will drop our data as well and metadata as well. Data means this Parquet file as well as this delta log, everything will be deleted. And so if we run this command, let's run this command. Okay, and then if I do this display, then it says file not found exception because it dropped everything, right? In earlier in this path we had our Parquet files, right? At this path we had our Parquet files and delta log, but because we have dropped this table, everything got deleted, and if I refresh this, then my manage table also got removed from here. Okay, so for manage table, both the metadata and the data dictionary directory including delta log and parquet files are deleted. It's completely wiped from this path. Okay, for external table, only the metadata in the Hive meta store is deleted. The actual data at the specific location is not touched. What you see on the left panel under the Hive meta store will disappear. So it got disappeared, but you can still go to my table and see this delta log. Okay, so let's do this drop operation for my table as well. Okay, so if we do drop my table, then from here we have now my table operation successful. If I refresh, then we don't have this here, but our data should be available here. So if I go to dbfs file table my data, and we still have this file, right? So if I basically read again, so if I just read my data again from that path, then we still see this data. Okay, because for external table only the metadata is removed, as we saw. So now I hope this concept of external and managed table is also clear. Now our last concept is vacuum. So what vacuum does is we had different transaction logs, so we had different versions, right? All the operations which we were performing is keep on appending, so we had now different versions available. So let's run this retain 0, and it will probably give this error, illegal argument exception, requirement failed. Are you sure you would like to vacuum file with such a low retention period? Because we have to be very careful before we use this vacuum command, because it will delete all the versions, right? If you have writers that are currently writing this to this table, there is a risk that you may corrupt the state of your delta table. Okay, so what we are saying here, just to test it, what we are saying, spark, we are saying retention duration check enabled false, we are making it false, and now safely we can run this command. So we are saying, okay, vacuum this path retention 0. If I run this one, okay, so this operation was successful, and now let's display this content of my table. So we see here only one file, and if we go to this delta log also, let's see what is inside our delta log. Okay, so here we see our delta log in, like, all the transaction logs are still there. Okay, so what vacuum does, so vacuum is basically only deleting the unused data files, like the old parquet files, but keep your JSON log files, because they are essential for tracking your delta table history, schema, and versioning. That's why we saw that in our my table we have only one parquet file. Old parquet files got deleted, right? The vacuum command in delta lake is designed to delete old parquet files that are no longer referenced by the delta transaction log. So vacuum is only for removing unreferenced data files, not cleaning your history. Okay, and now what we have here, just brief description. Describe history shows the version history of delta table, like a git log for your data. Basically what we were doing here, we were using describe table, right? We were using describe detail to table, right? So there is one more option called describe history, which shows the version history of the delta table, like a git log of your table. Shows version number, timestamp of the operation, user id, user name, operation performed, mode, any schema change, useful for tracking changes over time, auditing who did what and when, rolling back with version as of. So basically describe history will give you more information about user id, username, what operation performed. Okay, and describe details shows the table level metadata and details about the current state of your delta table, right? So that is the difference which I just wanted to also tell you. So with this we have reached to the end of our this hands-on video. Let me know in the comments how did you like it, and if you have any doubts, then yeah, let me know and we will try to solve that. In the next video we will understand more deeply about dbfs and db utils. And if you like today's session, then give us a like and subscribe to the channel for more data engineering videos. And soon we will also be uploading videos related to data scientist's role. So yeah, stay tuned and see you guys in the next one. Thank you. Bye.